We're going to go ahead and look at solving systems of equations. Now, a system of equations is a set of equations that uses the same variables. Now, systems of equations can either be consistent or inconsistent. If they're consistent, that means they have one or more solutions, which means if you are graphing lines, your two lines would have to cross once or more than once. Now, if they cross more than once, they are considered to be dependent because they're the same line. Now, if the two lines are not the same and they're different lines, they're considered to be independent. We also have inconsistent, which means the two lines don't cross, which means they'd have to be parallel lines. Now, systems of equations can be consistent and independent, or they can be inconsistent, or they can be consistent and dependent, meaning the same line. So, if two lines are consistent and independent, they cross at one and only one point. It means we have two totally separate lines that cross once. If two lines are consistent and dependent, they are the same line. Have infinitely many points in common. Or if the two lines don't cross at all, they have no solution and they are inconsistent. Now, your solutions to the systems of equations is where the two lines, or if you have three lines, where the three lines would cross. But for the most part, we're going to be just dealing with two equations, two variables, so we'll be looking to see where the two lines cross. Now, there's a couple ways you could do it. You could do it by graphing. So if we graph this, and for me, the easiest way to graph is to get them in the form of y equals mx plus b. So solve each one for y. So if I do that, on this top one, I'm going to start out at 2 and have a slope of -1. So I'll graph that. Now I'll go ahead and solve the second one for y, and I'll graph that. There I have a y-intercept being -3, and I have a slope of 2. So I'll start out at a height of -3, and then I'll go up 2 over 1, up 2 over 1. Now, my solution is the point where the two cross. Well, where do they cross? They cross right here. Now, if we look at that, and I think I'm going to change the color of that point so it stands out a little bit more, we want the coordinates of that. Sometimes when you're graphing, you can find the exact answer. Other times, you can only approximate it. So as I look here, based on my graph, it looks like it's a little bit more than 1.5 to the right. So my answer might be like 1.6 or 1.7, maybe 1.8. And I might be up about halfway. I can't tell for sure, so I'll say my y value is this. So sometimes when you're graphing, you can find exact answers. Other times you can only approximate it. So graphing gives you a nice visual of what's going on, but only sometimes allows you to get exact answers. Other times you approximate. So let's take that last problem we were just doing and solve it by using substitution. With substitution, you want to solve one of your two equations, either for x or y, and then plug it into the other one. I'm going to choose to solve the top one for y because I had just done that on the previous page. Now I'm going to take that y from the equaling 2 minus x from solving the top one for y and plug it into the bottom one. So I'll go 2x minus, now instead of writing y, I'm going to write what y is. It says y equals 2x minus 1, or 1x. So I'll plug that in. Still equal to 3. Now I need to solve this for x. Distribute through the negative sign, switches this here to a plus, solve it for x, and I end up getting x to be 5/3. which is 1 and 2/3. Now, you'll notice back here we had said about 1.6 to 1.7. Well, our answer is within reason then. Now, we have to plug it in to be able to find our y value. Now, if we know what x is right here, we could plug it in right here in the top one. We could plug it in right here in the bottom one. I'm going to choose to plug it into the blue one over here because y is on one side by itself. So all I have to do is just plug it in and simplify, and I get 1/3. And so my answer is the point where they cross. Remember, a point is the coordinates of a point, so it's the x followed by the y in parentheses. If you forget the parentheses, you're only listing numbers. You're not actually having coordinates of a point. Now, a third way you can solve systems of equations is with elimination. Basically, you want to try to get the same number in front of one of your variables, but one of them should be positive and one of them should be negative. You could choose to either get the numbers in front of your y's to be opposites, or you could choose to get the numbers in front of x's to be opposites. Doesn't make a difference. I'm going to choose to go ahead and get the numbers in front of my x's to be opposites, because if I just multiply the top equation by -2, I would then have opposites in front of my x's. I'd actually have to multiply by the top equation and bottom equation by something to be able to get my y's to be opposites. So take the top equation times -2, distribute this through, and I get this top equation. The bottom equation is exactly what I started out with here on the bottom one. Now all I'm going to do is add these equations together. -2 to the x's plus 2 to the x's is 0x's. -6y plus 5y. And -14 plus 10. So I'm just adding my equations. I solve it for y. I get y to be 4. All I have to do is take y being 4 and plug it into either the bottom equation or the top equation, and then solve it for x. I'm going to choose to plug it into the top equation. So I'm going to take x plus 3 times my y value of 4 and equal to 7, and that's what I have here. Now when I solve it for x, I'm going to get 12 here, so I have to subtract 12 from both sides. I get x to be -5. Remember, I'm looking for the coordinates of a point. My x is -5, my y is 4, which gives me the point in parentheses -5, 4. So looking at this one here, if we would use elimination, I'm going to multiply one of the equations by -1 so that my x's will be opposites. So I'll multiply the bottom one by -1. Top equation stays the same. Bottom one, I multiplied everything by -1. Add everything going straight down. And I get this. Now if my y is this, I plug it back into either one of these. To be able to figure out my x, I'm going to choose the top one, and I get x to be 2. So then remember to actually write the coordinates of your point, which would be 2, 4. Sometimes you actually have to multiply both equations by different numbers. Here, you'll notice I already have opposites on my y's, but the numbers in front aren't the same. So I'm going to multiply the top equation by 2, the bottom equation by 3. Top equation by 2, bottom equation by 3. Top equation by 2 gives me this, bottom equation by 3 gives me this. Now all I'm going to do is add my x's, add my y's. Well, 6y minus 6y is 0y, and then I get 57. So I get x to be 3. Now all I have to do is take x being 3 and plug it into either the top equation or the bottom equation. Doesn't make a difference. When I do that, and in this case I chose to plug it into the top equation, solve it for y, I get y to be 2. So my x was 3, my y is 2, so I'll write the coordinates of 3, 2. One last problem here. Here, if we go ahead and solve this, we can multiply the top equation by 2, and then I'll end up getting my y's to be opposites. And notice my x's are also opposite. So I'll add together my equations. I get 0 here, I get 0 here, so I get 0 equaling, and in this case I get 0 equaling 3. Well, we know 0 does not equal 3. It's a false statement, so that means nothing works. So these two lines don't cross. Well, the only way they don't cross, it means they'd have to be parallel lines. Now, if you were doing that and all your variables dropped out and you ended up with a true statement like 3 equals 3 or 0 equals 0, that really means there's infinitely many solutions and they're both the same line. So they're dependent.